Okay, this is section 10.2, and we're going through angles and arcs involving circles. Okay, there are different types of angles in a circle. The first one they talk about here is what they call a central angle. Okay, and we need to look at the definition of a central angle. A central angle has the center of the circle as a vertex, so it's got to go from the origin or the center of the circle, and its sides, the two sides of this angle, are radii. Okay, remember radius is singular, radii is plural. Okay, so this angle is a central angle. Anytime you got a circle and you've got a center, and doesn't matter the size of this, is a central angle as long as the vertex is at the center of the circle and the sides of the angles are radii. So they're saying angle AOB is what they call a central angle. There's a difference between when they have a central angle and we haven't gotten to it yet, like an inscribed angle. So you have to pay attention to the word central. Central angle has the center of the circle as a vertex, and its sides contain radii of the circle. And if you think about it, all the way around a circle is how many degrees? 360. And that's what they're saying here. The sum of the measures of all the central angles, okay, if I went all the way around, okay, the sum of the measures of the central angles of a circle with no interior points in common is 360 degrees. Okay? The sum of the measures of the central angles of a circle with no interior points in common is 360 degrees. Okay, so you can take a circle, okay, and you can split it up into several central angles. This would be one, this would be another one, this would be another one, this would be another one. But if you go all the way around, okay, that would add up to 360 degrees. Okay, so you just do a quick sketch of that. Okay, you take a circle, the center. If you add those all the way around, you just go all the way around, it's going to add up to 360 degrees. When you get into trig, we'll do it in radians. In radians, it adds all the way around to 2 pi radians. Okay? You'll get that down the road. Okay. Now let's look at an example. They will give you problems where you have to figure out an angle, part of an angle. Okay, it says given circle T with RV a diameter. So this is not just a math problem; it's also a reading problem. Given circle T with RV a diameter. So draw a circle all the way across, do a diameter. Okay, so my RV is right here. Okay, and they want us to find the measure of angle RTS. They want us to find this angle right here. Okay? So, label. Okay? Label first, this angle is 8x minus 4. Angle STU is 13x minus 3. Angle UTB is 5x plus 5. Okay. And then this angle is 20x. How can I solve that problem? Clue here, your clue Yeah, this is the clue. That's the diameter.
So apex minus 4 all or you do
Yep.
28 plus 8.
Yep. So let's do the 8x minus 4 plus the 13x minus 3 plus the 5x plus 5. Doesn't that get us halfway around? Get from the diameter to the diameter? Yeah. Or that gets us all the way around. And it equals what? 180. Because it's a diameter. That's half. Okay, now combine like terms. Okay, so you got to combine the 8x. And you can't ignore the signs. You got to look at the signs in front. Combine those, what are we going to get? 26x. Yep. And then combine minus 4 minus 3 plus 5. What is it? Minus 2 equals 180. Okay, then we can do the inverse, add 2 to both sides. Agree with that? Now I get 26x equals 182. Divide by 26. Okay, so you have 182 divided by 26, 7. Now, this is where it's a reading problem. If you were doing this on one of my multiple choice geometry tests, that would be an answer. But is that what they asked for? No. They want you to find the measure of angle RTS. So, the angle RTS is 8x minus 4. So if we sub in, we'd have 8 times 7, 56 minus 4, 52. Now, if I was going to check this, I would, if I was taking the test and I wanted to check it, I would actually find the other two angles and then make sure they all add up to 180. Okay? So, this would be my answer, 52. Okay with that? So if it's all the way around on a circle, it's 360. If they give you the diameter halfway around, 180. Okay? Everybody okay with that one? Okay. Okay, the next part. A central angle separates the circle into two parts called arcs. A central angle separates a circle into two parts called arcs. Okay, and draw an example of a circle. Label it. The B is the center. Okay. Label it the way I've done here. Label A, C, and B. Now the two arcs have special names. Okay, one is called the minor arc. The minor arc is the measure of the central angle that's less than 180. Okay, so this one would be less than 180 because it doesn't go through, it doesn't, like the, if it's a diameter, it's 180, so it's less than that. Okay. And a minor arc, you label it with two letters. With instead of a straight line above it like a line segment, okay, you do just an arc. Okay. When you talk about the measure of it, you use an M in front. Okay, and you say the measure of arc AC is less than 180. Okay. So it's a little bit on the notation. Okay, then the other part of the circle, this part, okay, where it would actually be like an obtuse angle here, bigger than 180, that's called a major arc. Okay, a major arc, that's the measure of the central angle greater than 180 degrees. A major arc is the measure of a central angle. It still has to be a central angle. Okay, and a major arc greater than 180, you use 3 letters. So if they're giving you 3 letters in an arc, you already know the angle's bigger than 180. If they only give you 2 letters, you know it's less than 180. Okay? And this basically saying the same thing, the measure of arc. And notice the way they wrote it. A, they have to go in order. A, D, C. Could they change it around and go arc C, D, A? Yes. Okay? But it's got to be, don't put D on the end. D has to be in between C and A. Okay? Makes sense? Okay? Then they define the semicircle. Okay? The semicircle, we just used that basically on the problem we solved. The semicircle, the arc is equal to 180. Okay? And the semicircle, notice they use 3 letters, and it's basically all on the diameter. And the F has to be in the middle. Okay, could I turn it around and say arc G, F, E? Yes. Okay, but it's equal to 180. Okay, so minor arcs 2 letters, major arcs 3 letters, semicircle 3 letters. Okay. Okay, then they go through some theorems. Okay, the first one is Theorem 10.1. Okay, Theorem 10.1 says, in the same or in congruent circles, in the same or in congruent circles, 2 arcs are congruent. IFF means if and only if. In the same or in congruent circles, 2 arcs are congruent. IFF means if and only if. Their corresponding central angles are congruent. The IFF, this part means it goes both ways. It means when you're reading this, in the same or incongruent circles, 2 arcs are congruent if and only if their corresponding central angles are congruent. Then the other way, because it's if and only if, that means it goes the other way. If their central angles are congruent, then the 2 arcs are congruent. So it goes both ways. So I've written it out both ways. If you have a circle, okay, draw this circle, okay, and try to label it, okay, and 1 and 2 are actually congruent. Okay, so they need to look about the same size. Okay, these need to look the same size. Okay, if angle 1 is congruent to angle 2, then their arcs are congruent. If this angle is congruent to this angle, then this arc, FG, and that's a minor arc, is congruent to HJ. Now that's the if part. Now here's the if and only if. The only if is you turn it around. You just turn this around and say if the arcs are congruent, okay, then the angles are congruent. Okay? So anytime you see that if and only if, that means it works both ways. It works both directions. Some teachers they'll do it like that. That means it goes both ways. Okay? Okay? So if arc FG is congruent to arc HJ, then the angle 1 is congruent to angle 2. Okay? And you're going to use that when you're solving the problems. Okay? Okay. Okay. The next thing is adjacent arcs. Okay, adjacent arcs. Arcs that have only one point in common. Okay, here's an example. Draw a picture. M is in the center, and then H, J, and K. Okay, adjacent arcs, like HJ is an arc, JK is an arc. They are adjacent because the only point in common is the J. Okay, There's only one point in common. Another way to say that is basically they have to be touching like that, right? This angle and this angle. Okay. Okay, then there's a postulate, 10.1, that's called arc addition postulate. The arc addition postulate. First, draw a circle. S is the center. And then put a point P, a point Q, a point R in that order. Okay, now you can add the arcs. The measure of arc PQ plus the measure of arc QR equals the measure of the whole thing, PQR. That's angle or arc addition. Instead of angle, we had angle addition earlier. This was arc addition. So it's the measure of arc PQ plus the measure of arc QR equals the whole arc PQR. Okay. Okay, then on some of the problems you're going to need to use a proportion when you solve it. Minor, but yeah, but you have to do it, you have to write it that way. Yep. There's no way to get around that. Yeah. Okay. Good question. Yep. Okay. Now, when you're doing some of the problems, you're going to need to use a proportion for the arc length, okay, or length of the arc, okay. Arc length is the distance, okay, like linear measure, the distance between the endpoints along an arc, and it's measured in, it would be like if I took a circle, let's say I take a circle. If I take a circle and here's and I measure in, let's say, inches, if I took a string and laid it along the edge, the length of that arc, so it's a distance. Okay, now, there is a proportion that you can use to solve some of these problems. It's the length of the arc. The length of the arc is to the whole circumference of the circle. And set that equal to the degree measure of the arc, like if I said that if the arc was 50 degrees, okay, to the whole 360 degrees. So this is basically the length of the arc to the circumference of the whole circle equals the degree measure of the arc to the whole degree measure of the whole circle. Okay. Then the length of the arc, they're using L. I don't like that they're using that script L. I like a capital L better. If you want to use a capital L, that's up to you. Okay, and the circumference of a circle, we had two formulas for circumference of a circle. The author's using one, 2 pi r. What's the other one? Pi times diameter. So you could, if they give you the diameter, you could use pi times diameter. And then x would be the length of the arc, okay, or not the length, the angle. So like if they told you the arc was 75 degrees, you put that in, and the 360 is the degrees in a circle, okay? And then you cross multiply to solve a proportion, okay? Okay, I think that should be it. Should get you started. Yep. Okay. Anybody need more time on that formula? Okay, I'm going to give you time to work, okay? Finish that assignment for tomorrow, okay?